This video will go over the Pangaea fossil evidence activity. Directions. Number 1. Use the South America and African fossil record image and your understanding of fossils and superposition to answer the following questions. It's important here to remember that superposition is the idea that older fossils are underneath layers of newer fossils. The oldest fossils are always the deepest down. As Earth generates new layers of soil, the older fossils are buried deeper and deeper, just like the ice cores that we talked about in the beginning of the year. Now the image you're going to open will look like this. It is going to look small probably on your screen because it's a very large image. You can zoom in on it. I'd recommend zooming in pretty far so that you can read the names of the fossils on both the South American side and the African side. Direction step 2 says on the South American and African fossil record image, the left side shows the fossils found in South America, and the right side of the image shows the fossils found in Africa. Okay, so looking at it, I can imagine I'm a scientist in South America. If I dig down, these are the layers of fossils I'm going to be seeing. Similarly, if I'm a scientist in Africa and I dig down, these would be the layers of fossils that I would find. Now you'll notice in between the two is the Atlantic Ocean. Right now there's no way to walk from South America to Africa. The Atlantic Ocean is in between. In fact, step 4 says, today the Atlantic Ocean separates the two continents. Lastly, number 5, the age of the layer is included on some of the cards. For example, 180 MYA, which stands for millions of years ago. So a fossil that says 180 MYA means that those fossils are from 180 million years ago. Let's see if we can find an example. So this is much too small for me to see. I'm going to hit the plus button to zoom in. Maybe one more time. There we go. And now I can see the names of these fossils pretty well, plus some really cool dinosaur pictures. All right, looking at this first layer, if I dug down in South America and Africa, I would hit a layer of rock roughly 70 million years ago. Within these rocks, I see three different organisms. I see a raptor, some sort of large carnivore, and another large carnivore. I'm noticing that these three species are not the same. That's going to be important. Let's go back to our questions though. So step 1 says analyze the data. List 3 dinosaurs that lived on both South America and Africa. All right, so my job will be to scan through the fossils and be looking for dinosaurs that are the same on both sides. All right, looking down. Not seeing any connections yet. Oh, looks like I might be lucky here. Let's see. 100 million years ago. Lutrosaur. Nope, no matches. But underneath that layer, I'm seeing Condoraptor and Condoraptor. It looks like right here I'm seeing one of my matches. So if I'd like to, I could write that the Condoraptor I think I misspelled that. Sure did, 2 R's. Condoraptor lived in both South America and Africa. Now I could do the same thing, but look for only 2 dinosaurs that only lived in South America. So if I came down further, for example, Condoraptor would not be a good example because it's in Africa and South America. And Stegosaurus is also not a good example because it lives in South America and Africa. So I could look for a dinosaur that only lives in South America. And in fact, I'm going to do the same thing for those dinosaurs that only lived in Africa. All right, coming down here, did Condoraptor ever interact with Stegosaurus? Now this is an interesting question. Did this dinosaur ever fight or eat this dinosaur? That's an interesting question. Sure, it looks like this meat eater could eat something like this. I'm going to remind you that these different layers represent millions of years of time. And I will also remind you that organisms in the same layer that could interact would have to be connected by land, and they'd have to be during the same time period. Similarly, did the Scorpio venator ever interact with Euraptor? Interesting. You can go through and find those two organisms and see if they look like they might interact. Coming down to the extend, these are the questions that really are going to help you understand this idea of Pangaea and continental drift and how the continents may have moved. Number one, why is it important that some of these land dinosaurs, you'll notice none of these are aquatic or swimming dinosaurs, none of these are flying dinosaurs. These are all enormous dinosaurs that could not possibly swim across the Atlantic. So why is it important that some of these dinosaurs are on both continents? Based on the fossils, when do you think Pangaea broke apart? I'll remind you, if dinosaurs are interacting, it's because they lived at the same time and they were able to walk from one place to the other. Last few. Why can't scientists, like you, be certain of the exact date Pangaea broke apart? And how does this evidence support the theory of continental drift? As always, I'm a text message, email, or phone call away. If you have any questions, please feel free to reach out. And otherwise, good luck.